Guys, welcome to this particular session of this video. So in case if you are interested in learning machine learning by making use of Python programming language, you are welcome to the right path, to the right channel to learn that. So in this particular session of this video, we are going to make use of sklearn. You can see Scikit-Learn. As you can see here, this is the website. We can try to go to user guide, API examples, but I just want us to look at what this sklearn can actually do. This is their website. You can read a whole lot of documentation like I've stated earlier. But what is actually this sklearn? This sklearn, or you can say Scikit-Learn, provides us with a library in Python that we can use to actually implement those of the machine learning. Can say machine learning algorithms or machine learning formulas. When it comes to the ideology actually behind machine learning, mainly a mathematical formula. So with the help of this sklearn, we can actually implement all these guys really easy without us needing to actually start from scratch to start writing it by ourselves. You can actually write out some of all these machine learning models by yourself if you actually have the time or the resource and the capability to actually write some of all these models by yourself. So when we look at this Scikit-Learn website we have here, you can see that machine learning in Python. This is sklearn, like I said, is for Python. And other programming language might have some of the library they make use of. But in this of our machine learning tutorial, we are going to mainly make use of two libraries or two framework in Python, which is that of the first one is this of the sklearn, and the second one is going to be that of the TensorFlow. So the reason why we're going to make use of these guys, because when we look at this sklearn, it tends to have a little bit of limitations. Limitation is not actually that limited, just that they tend to focus more on that of the data can say supervised and that of the unsupervised learning. So for making use of that of the TensorFlow, we are going to dive into that of can say the reinforcement learning on that of image recognition, maybe deep learning, and a whole lot of other stuff. So with help of this sklearn, well, let's look at the simple and efficient tool for predictive data analysis, accessible to everybody, usable in various contexts, built on NumPy, Scikit, and Matplotlib, open source, commercial usage, BSSD license. So what is actually this actually mean? When we look, it's actually built on top of NumPy, the Scikit, and that of the Matplotlib. We know that this NumPy is actually for for a whole lot of computation, a whole lot of mathematical manipulation. That's one of the power of this NumPy, and this guy Scipy also also for computational. And for this Matplotlib, we are going to do a separate video on this of the Matplotlib, because this Matplotlib, like the name plot, is what it actually does is just to can say to create let's say in a station where you feel like you want to draw graphs. So that's one of use of Matplotlib, to draw graph, visualize what your model is actually doing, to do a lot of things. This Matplotlib is actually a good we can say a good library in Python. So you can say that is an open source, commercial, usable, simple and efficient tool for predictive data. So what is the use case of this of the sklearn? That I know some of this is not the first time that we are here now, but this sklearn, like I said, is a library in Python programming language that we can use to actually implement our machine learning algorithms, or machine learning mathematical formulas, and a whole lot of other stuff. So that's what the main aim of this sklearn. And this sklearn tend to mainly focus on two aspects of machine learning, which is that of the supervised and that of the unsupervised. There's actually some rumors, I cannot rumor, there's also some case that I've seen it mainly being used in that of the hand digit recognition, which is a little bit of that of image recognition. So we're making use of that of MLP classifier, which is actually like a sub part of neural network. It says sklearn tend to handle that, but the main focus of sklearn is mainly for that of the supervised, unsupervised type of learning. And what is actually this supervised that I've been talking about? Supervised type of learning is more like in a situation whereby you have the data available, and then you give the model both the data set itself and with the point you are trying to figure out. When I mean the point, I mean your target, what you want to actually predict. So that is actually supervised. While unsupervised learning, when it comes to unsupervised learning, it's more like this is just like a simple ideology. It's just unsupervised learning is more like in a situation whereby you don't even know the target and that of the data that we have available. But let's look at what sklearn is able to handle. How that of the classification, what of the regression, the clustering, what will go down, how that of dimensional reduction, model selection, pre-processing. To do all this is by making use of sklearn, and that this our machine learning tutorial, and also we are going to do similar thing that of the TensorFlow. So when we look at this classification, when we get a data can be categorized into a whole lot of categories, which you can have that of the string, we can have that of the, can say, variables, sorry, you can have that of the string, and then we can have that of the, can say, numerical, have the boolean. But we know most times machine learning algorithm tend to take that of the numerical, which can be, with numerical, I mean numerical, can be that of the integer and that of the float and that of the complex numbers. But we are going to, most machine learning, I don't think actually make use of things to take complex numbers. So we are going to actually focus that more on that of the integer and that of the float. So classification is more like okay, you know this can be yes or no, more like a boolean, like when you say identify which category an object belong to, span detection, image recognition. What does this actually mean? Let's say in a situation whereby you have a model that actually predicts maybe if a message is actually a spam or is message is not actually a spam. This is one of the advantage of classification. What does this actually do? It just classifies something, whether if let's say example 1 or 0 is a spam or is it not a spam. That's just basically simple as that. For image recognition, as you can see here, what does this actually mean? This is in the simplest thing. You can see like how I will explain this of the span detection. With this image a bird, it's not a bird, maybe it's a cat. So simple as that. But I can see the algorithms, the gradient booster, boosting nearest neighbors, random for logistic regression, and a whole lot of them. So what is this regression? Remember when I talked about this classification, it's more like 1 and 0. Not like 1 and 0, it's just like more like a discrete, meaning that it can either be this or it's true, or for whether if it's this or it's not this. But when it comes to that of the regression side, the regression side can be a little bit confusing when it comes to this classification. Regression is more like a continuous valued, can say a continuous value, like that of the float. When we're talking about, for example 1.25 something, maybe, or 3 point something. That is what regression is for. Let's say in a situation whereby I want to predict the market price, or maybe the price of something that is actually continuous. This is where you are going to make use of regression. Most times classification models tend to outperform regression models due to some other things. Like you can see that some of the application, like when we look at the drug response stock price, that stock prices, we all know that stock price is not going to be something like maybe 2,000 or maybe 5,000. It's going to be 5,000 something, maybe 5 point something. I think that's actually simplest ideology to actually understand this. So these two regression and this of the classification mainly fall under that of the supervised learning. This of the clustering, this clustering is more like that of the unsupervised learning, like whereby maybe the noise, the data is actually that noisy, and sometimes the target doesn't really have a value assigned to each of them. Don't worry, I was also going to understand. I just want us to have a little bit ideology of what clustering is. And I can say this classification and this regression for on that of the supervised learning. And then when we talk about this regression, they have the algorithm that's available, gradient booster, nearest neighbor, random friend range, and a whole lot of more. But in this of the classification, that's what we're going to have, that of the logistic regression, decision trees, whole lot of the gradient booster, classifier. Most of the time be hearing classifier at the end, classifier. They all belong to that of the classification. And then at times you'll be hearing regressor, maybe random forest regressor, gradient boosting regressor, linear regression. Also, I've forgotten some of them. And then this clustering of a guide mainly fall to that of the unsupervised, and we have the application, customer segmentation, group experimental outcomes. So this is one advantage of where this clustering actually comes. But most of the time, people that mainly make use of this of the clustering are more like malls, people that actually sell stuff like shops. They make use of it. Let's say in a situation whereby you want to buy maybe something like milk, we can make use of clustering by that of the shop by getting what people that have actually bought milk earlier or maybe years ago till up to date. They can actually cluster make use of this clustering algorithm to actually predict the next thing that you are likely to buy. I know that when somebody buy milk, there's more likely possibility that you might end up buying maybe adding bread to it and a whole lot of other stuff. So that's when this clustering of a guy actually come into play. So with that, like, I remember that this clustering tend to fall under that of the unsupervised learning. So let's go down a little bit. We have this of the dimensional reduction. We have the reducing the number of random variable to consider. We have that of the PCA, feature selection, non-negative matrix, factorization, and more. We are going to make use of the ideology behind this dimension reduction. What it actually does is, like, let's say in a situation where I have a whole lot of features. When I mean features, I mean like can say the table, maybe the table name, or sorry, each column must have a name or maybe have a title like that of the name. Maybe that is, let's say, something like first name, second name, so, and maybe age. These are features. You know what I mean? With the help of this dimension reduction or this feature selection and a whole lot of other things that actually come under this dimensionality reduction, we can actually reduce those of the features for us to actually get the best feature, because some features can that will have, you can see, random variable tokens. Some feature that we might have in our models can be causing a whole lot of noises and a whole lot of messing up our model. That a model can cause a whole lot of bias, can say under, and a whole lot of overestimation. With the help of this dimensional reduction, we can actually handle that. And the sklearn tend to provide us with this PCA feature selection. I remember that all these things you can actually write them from scratch, but with the help of this sklearn, you don't need to actually write them from scratch, because the advantage of this sklearn model that would, all these external libraries that we make use of, is the advantage that it's been written already. Since it's been written already and it's been tested over and over, and then to actually I find maybe there are some things that are actually messing up, but it doesn't actually stop you from actually starting from beginning to write your own, because as you go, we're going to write that of the linear regression and that of logistic regression by ourselves. So, and this of the PCA, even some of the features, we're going to write it with pen and paper. Then we can actually understand how it actually came out. Then we're going to compare it with the output that sklearn tend to provide for us, and have this of the model selection, comparing, validating, and choosing parameter model. The application improve accuracy via parameter to have the grid search, cross validation, metrics, and a whole lot of more. This grid search we are going to make use of, this cross validation we are going to make use of. Like you can see, the application is to improve accuracy via parameter tuning. That is just the main reason of some of all these model selection. That this grid search, what you actually do is to actually it's more like actually brute forcing, not actually brute force. Just like we know each model tends to have a parameter that you can actually set, maybe to actually fine tune the model to actually get a higher accuracy. So with the help of this grid search, let's say you said, maybe for example, maybe you set the max depth of a particular model. Let's say example like this linear, if something like this random forest, you set the max depth to something like maybe 100. You can see that if you run the model again, maybe you want to check whether if 200 is going to perform really well, you set it to 200, run the model again. But with the help of this research and this course, there are a whole lot of them, like random SV, there are a whole lot of them. We can actually set maybe the model we can set the number from maybe 0 to maybe 500, and this grid set is going to automatically just go through each of them and find the best the best parameter that actually has the best accuracy, that improve the accuracy of the model. This grid search can be quite resource intensive, but at times even till up to date, I don't think there's any any fine-tuning model that actually outperform this grid search. It's just that it tends to be really hard to actually it's kind of resource intensive, that it can actually hit a whole lot of can say a whole lot of GPU or a lot of CPU on your system, and it can be a little bit slow. But we have that of the Optuna, which is actually, I think most people use it right now these days, but research can still never beat research. Just that research kind of research intensive. So that is it for this model selection. Remember, as we go on, we're also going to get a lot of things, and then have that of the pre-processing, feature extraction, normalization, transforming input data such as a test for use with machine learning algorithm. We have the pre-processing, feature extraction, and a whole lot of them. Normally for you to actually get your models running really well, can say your algorithm or the scaling, you need to, or for you to get a higher accuracy on your model, let's say in a situation whereby you're using random forest, or maybe gradient boosting, nearest for a whole, maybe logistic regression, any one of your choice. In your data need to be actually pre-processed properly, because if it's not pre-processed properly, you are going to have issue. And for pre-processing, we have that of the some of us might have had about one hot encoder. We have the label encoder, we have the simple input. There are a whole lot of ways to actually process your data to actually make it to actually with the help of pre-processing. What actually does, it can actually improve the accuracy of your model, and to actually maybe to make your model even, to make your data even make a whole lot of sense, or have that of the normalization and a whole lot of other stuff. So we're still going to look at this really when we start the make use of this sklearn to actually do a whole lot of things. So these images and some maybe the output that is being gotten, and there's the predictive average energy transfer during the week. This is all these images that you can see here. These are more like graphs that are made by making use of this of the matplotlib. So we are going to see find ourselves to this point that we can actually see. So when we go down, we'll have this is for dimensional reduction, the model selection, and that of the pre-processing. So when you go down more, there's not really much on that. So I think with this, we've actually covered a whole lot of things concerning this of the sklearn. Remember that sklearn is actually a library in Python programming language, which is being used for machine learning in Python programming language. Just simple as that. As you can see here, you can actually call it sklearn or that of the Scikit-Learn, any one of your choice, and it was built on top of NumPy, CP, and that of the matplotlib. It's an open source. You handle that of the supervised and that of the unsupervised. And then for supervised, we are going to make use of classification and regression, unsupervised clustering, and then when we go to that of the reinforcement learning, we are going to encounter that of something like qlearn. So we are going to encounter that of the when we go into that of the reinforcement learning, we are going to come in contact with that of the qlearn and a whole lot of other formulas out there for that of the reinforcement learning. sklearn don't tend to handle that of the reinforcement learning. I don't think so. But actually, sklearn can handle some kind of deep learning like that of a little bit partial of the image recognition and some other few stuff. So, but when it comes to that of reinforcement learning, we are going to make use that of the qlearn, which is one of the simplest. So we are going to, the main aim of qlearning is different from that of the supervised and that of the unsupervised. So when it comes to qlearn is more like you are going to introduce an agent to a particular environment, and what does that agent is going to do? Is going to find the best, I can say the shortest path to maybe to find something that you want to actually do. Let's say now tic-tac-toe board for example. Let's say we have the tic-tac-toe board, and then maybe you want the maybe when maybe the AI, maybe there's a win opportunity, you want the AI to actually get there to get the highest reward. When it comes to that of the reinforcement learning, you make use of all things like, you hear some things like state, we hear things like reward, we hear things like actions, and a whole lot of, we hear things like Q table. These are some of the things that qlearn comes with, and it focuses on that of the reinforcement learning. So let's not make things a little bit complex. Let's actually when we start with this, let's actually understand that of the supervised, the unsupervised, and then we can dive into that of the reinforcement learning. So the next thing we are going to actually do is actually to have our sklearn installed, because I don't think we're going to start making use of it right now if you don't have it installed. So the simplest way to install it is go to your command prompt. If you are making use of maybe if you have a separate environment, maybe you created a different environment, you can dive into that of the environment, and then you can actually install it right there. So that's basically what we're going to do in the next video. So I'll be happy to see you in that video. Thank you for watching.